Welcome to the Phenomenological Alliance channel. In this video, we will highlight the fundamental difference between phenomenological methodology and the methodology of mainstream science, namely, an endeavor to free oneself from hypotheses.
The geometric model of light emerged in antiquity, although during ancient times, the interpretation of light rays differed from today's customary understanding. Subsequently, with a focus on mathematical modeling in physics, public opinion embraced the idea that rays of light depict physical reality. Today, rays of light are viewed as the trajectories along which photons, the elementary particles of light, travel.
Let's explore the real meaning of the concept of a ray of light from the standpoint of light as appearance. In order to understand light as a phenomenon, let's consider one of the basic optical experiments, namely the experiment of focusing light with a magnifying glass. Let's ask ourselves, what do we actually see on the screen? It's very likely that by habit and thinking, we might believe we see the focus of rays of light at the point. And yet, in the answer to this question lies the difference between what we are taught to answer and what we actually see. Because when we focus sunlight, we certainly do not perceive light rays at the focal point, but rather a bright spot. If we question what that bright spot represents, we easily conclude that it represents a diminished image of the sun. When we focus the light of a lamp with glowing filaments, we see a bright spot at the focal point only if the image is not sharpened. When the image becomes sharpened, we can clearly see the image of the filaments. When we focus the image of a watch, we see the image of a watch on the screen. Thus, we can focus as many objects as needed, but one common determinant always remains, the concept of the image. From the standpoint of appearance, light is a transparent image. With such insight, it becomes possible to understand that the transparent light image is blended with the image of the screen. On a white screen, the dark parts of the transparent light image will be more pronounced. On a black screen, the bright parts of the transparent light image will be more pronounced. The image is visible on both black and white surfaces, and there is no need to introduce a special hypothesis for how an image is visible on a black surface, which is believed not to reflect light. The phenomenon of the darkened chamber implies that we observe an image through an opening, and this opening constrains our field of view. This helps us comprehend the age-old question posed by Aristotle. Why do we see a circular object on the screen even through a triangular opening? The answer lies in the fact that we are observing a circular object through the opening. The limitation of the field of view does not affect the appearance of the original image. It is not about an illusion of shadow, but rather an illusion of thinking.
The basic question of phenomenology as a method is the question of conscious experience. In optics, this approach raises the question, what conscious experience do we get through the perception of light? We readily conclude that the perception of an image is a fundamental aspect of the experience of light. The light rays of geometric optics reflect reality, but only if they are drawn together with the eye and experienced as principles of perspective. In optics, as long as we are aware that we are considering an image, we remain in the realm of the factual, and do not enter the dangerous zone of hypothesizing. But, when we start to draw the light rays without an eye and begin to consider them as a physical reality separated from the process of visualization, then we separate ourselves from the obvious fact and our conscious experience. Both the corpuscular and wave theories of the nature of light emerged when observations of phenomena gave way to contemplation based on hypothetical models of light. As consciousness diminishes, it creates room for a sort of hallucination regarding reality.
Phenomenology tries to stay in the sphere of facts in such a way that phenomena describe phenomena without assumptions. With this conclusion, we end the first block of topics dealing with the application of phenomenology in physics. The continuation is in the second block.